Good morning, everyone.
Good morning.
Is my screen and voice clear?
Yes, sir. Yes, sir.
Okay. Yeah. So, good morning, class. So, in the Monday session, we have started about the actual proceedings, that is with the DFA. Many of you had encountered many doubts regarding the topic as to how to construct the machines and all. Okay. What I will do is in this session, I will start the next topic, my NFA, so that I will map NFA to DFA so that things will become somewhat easier for you. Okay. I will construct the second machine, my NFA, and from NFA, it will be very easy than DFA. So once you get hold of the NFA, then I will map the differences between NFA and DFA so that you can have a clear-cut understanding of the topic. And one more thing is we are very much lagging behind the syllabus. We have requested the authorities to conduct the mid-examination for the flat subject for the up next Monday. As we are having 6 subjects now, that entire next week you will be having 1 subject each day, and coming one Monday, we have requested the authorities to conduct the flat exam for the up next Monday, but still I'm not sure whether we could able to cover the first unit or not, because the academic calendar is such. And previously for your seniors, there used to be 4 sessions every week for the subject flat, but as per the new regulation, flat is a 3 credit course, and as per the new regulation, every credit, should correspond to the hour. So we are having only 3 classes, that's the problem. Okay. So I will explain NFA in this session, and I will map the differences between NFA and DFA. Okay. So the second automata machine, that is NFA. Non-deterministic finite automata. So previously we have seen DFA. I will just keep aside now. Previously we have seen DFA. It is deterministic. Okay, it has 5 tuples. We have seen the 5 tuples: Q, sigma, delta, Q naught, and F. Right. So this is the base that we have done so far. So now coming back to NFA. Okay, it is non-deterministic finite automata. So I will explain all the difference and all. So first thing is it is non-deterministic. And second point is it too is same as a DFA with 5 tuples. The same 5 tuples it is also having. So Q, sigma, delta, Q naught, and F. Okay. So the main difference is in DFA, what is the function? Delta is Q cross sigma is Q. You have seen like this, right? For example, Q naught comma 0 is Q naught. Q naught comma 1 is Q1. So this is the transition function we used to have in DFA. So from one state, if you take an input, what is the state you will be reaching? So this is the transition function of DFA. Q cross sigma is Q. Okay. Coming back to NFA, the same 5 tuples we are having. Q is the number of states. Sigma is the input alphabet. Delta is the function, transition function. It is the initial state. This is the final state. So the 5 tuples are same. The only difference is with the transition function. So for NFA, the transition function is as follows. Q cross sigma is 2 power Q. Okay. So this is the main difference, guys. In DFA, it is Q cross sigma is Q. Whereas in NFA, it is Q cross sigma is 2 power Q. That means by this basic function, you can say that NFA has more number of states than DFA, or it can, from one state on one input, we can go to greater number of states than the DFA. That is the main difference. Okay. Now I will show you with the help of 2 simple block diagrams the difference between DFA and NFA. So first I'm talking about the DFA, the previous topic, the first machine. So it has an initial state marked with arrow brace. Let's say Q naught 1. Let's say it's going to Q1. So this is the final state. A simple machine which accepts 1. Okay. So this is a DFA which accepts the input only one. So from initial state you start, take the input 1, you reach the final state. That's it. Okay. So this is DFA. If the same DFA, if I want to say 1, it is already accepted. If I want to make the machine accept 0, 1, okay. If I want to make it accept 0, 1, I have told you a notion, right? Based on the minimum string, add 1 to it, you will get the states. So for my DFA to accept 0, 1, as the length of the string is 2, I should take minimum 3 states. So now Q2 will be my final state. Q1 is a normal state. It won't be final state. So this is Q1. Now this is 0, this is 1. Clear? So this is the DFA that accepts the string only 0, 1. Okay. So now if I want to alter any of the DFA, I can alter as follows. See, take the case of Q0. On Q0, on 0, it is going to Q1. So Q0 on 0 is Q1. That is 0 is done. In DFA, I cannot take any more zeros to other states. Instead, watch this very carefully. I can write like this. Q0 on 1 is Q3. This is valid. This is a DFA. Okay. So again, 1 is taken. So Q0 on 1 is Q3. I cannot take any more ones. Or I can take like this. Q0 on A is QA. Okay. So this is in my DFA. From one state on an input, I can reach a unique state. Okay. I cannot reach Q3 from Q0 with the help of 0 because 0 is already reserved as a path for Q1. That is the main difference as DFA. So it is very deterministic. Okay, you can see the degree of determinism in this automata. From one state, the paths are very clear. You take 0, you reach Q1. You take 1, you reach Q3. You take A, you reach QA. Okay. You cannot write like this. Okay, in DFA, from one state to another state, there exists a single path over an input. That is the main difference. Coming to NFA, the second machine. Watch this very carefully, guys. NFA, I can have like this. So Q0, the same. In order to accept the string 1, Q1, this is the final state. If I want to make it 0, 1, I can write like this. Now see, Q0 on 0, it is going to Q0. And Q0 on 1, also, sorry, it's Q1. And Q0 on 1, it's also going to Q1. Okay. This is the difference between DFA and NFA. Okay. You can also write like this. So Q0 on 0, you can go to Q2 also. Okay. So in DFA, from one state on one input, you can reach only a unique state. Whereas in NFA, the second one, non-deterministic finite automata, non-deterministic. So that's why the name. From Q0, you can take a Q1 in multiple ways. If you take 0, you will reach Q1. If you take 1, still you will reach Q1.
Sir, from Q0, if we are taking 0, how are we going to Q1? It's still in Q0 only, right?
Sorry, this is Q0. 1 second. Yeah, so Q0 on 0, I will go to Q2. Yeah, it's clear now?
Yes, sir.
So Q0 on 1 is Q1. Okay, sir, my mistake. Okay, so in NFA, from one state over an input, you can reach multiple states, just like the case of 0. In the same way, you can also have 1, 2 like this. So Q0 on 2 is same as Q2. Okay, so
Sir, so in NFA, we can have other than 0 and 1.
Any input, ma'am, just explaining it as an example.
But in DFA, only 0 and 1 are allowed, right?
No. You can take A, B, C, whatever you wish. All these are example cases.
Achha,
Not
okay.
that there is a constraint that DFA should only accept 1s and 0.
Okay.
If I ask DFA over the alphabet A, B, let's say starting with A or only accepting A, the same machine will be like this. Q0 on A is Q1.
Sir, so can it have more than two? Like here you have given A and B. Can it have A, B, C like that?
It can have as many inputs, ma'am. Just explaining it as a basic case of example. That's it. You can have 26, all the A to Z as input alphabet, and you can have as many strings as possible.
Okay. Actually, I thought it was only two like that.
No, not. I mean, but in most of the cases, or in the previous question papers, or any examples over the internet, if you see, mostly the input size will be restricted to 2 mark.
Why, sir?
It is, I mean, coming as the age-old standard. That's it.
Okay.
I mean, the input can be only of characters too, but it can have multiple iterations, right? It can have A, B, AB, BA, ABA. Any combinations is possible, right? So this is the main difference between DFA and NFA, guys. I hope you are clear with the topic.
Sir, we have A, 1, 0. These three are distinct, no, sir. Q0 to
A1?
0. Q0 to QA, it is A. And Q0 to Q3, it is 1. And Q0 to Q1, it is 0. So these three are distinct. Whereas in NFA, Q0 to Q2, it is 0. 2 times 0, it is given, sir. So here we can repeat, and in NFA we can repeat, and in DFA we cannot repeat.
That's the main difference now. In Q0, from one state, you can, I mean, if in order to reach another state, you should have a distinct input.
Okay.
The same is not the case with NFA. In NFA, from one state, you can have multiple inputs to same state or same input to multiple states also. Both ways it's possible. Okay?
Yes, sir.
Let me explain this concept now. So in the previous class, I think we are struck with the topic. Epsilon or sigma is 0, 1. Design a DFA that starts strings with 0, 1, right? This is where all the confusion has happened. Now, not DFA, I'm asking NFA. So design an NFA over the alphabet 0, 1 such that the string starts with 0 and 1, or string starts with 0, 1. So what is the minimum string, ma? I mean, this is the minimum string, right? 0, 1. The length of the string is 2. So what will be the number of states?
2.
No, number of states will be 3. So see, ma, carefully. Whenever the constraint is as follows, starts with 0, 1, you can have it as a main path. So this is the main path leading from initial to final, right? So whatever the constraint is given in the question, make it as a main path, 0, 1. Now, if the string is starting with 0, 1, it can also have 0, 1, 0, right? So 0, 1, make it a 0. Or it can also have 0, 1, 1, right? 0, 1, already 0 is given. But as it is NFA, watch this very carefully. As this is NFA, I can also have 1 here, 0, 1. So this NFA will accept 0, 1, 1. If I want 0, 1, 0, 1. So 0, 1, it will take 0, again it will take 1. So this is very easy to construct now. With the same concept, if I would have asked in DFA, we have seen the degree of complexity in the previous class. So the same question mark, I want a DFA over the alphabet 0, 1 such that I want string starting with 0, 1. Okay. If the same question is asked in DFA, the first step is almost same. You have 3 states. You have Q0, you have Q1 and Q2. Now 0, 1. So make it as a main path. Okay. This is fine, ma. This is very good. But what if it is want 0, 1, 0? The same case. If the DFA need to accept 0, 1, 0, make it 0. As Q2 is not having any paths, you can have 0, 1, 0. Fine. Then what about 0, 1, 1? It is a DFA. You cannot add 1 here. Okay. So here the minimal DFA concept is not valid. Okay. In DFA, the concept of minimal state DFA no longer holds good based on the string. If I want to have 0, 1, 1, I cannot modify this because already I have given this. One option is 0 or 1. I can add like this. Okay. In DFA, you can go like this, /1. There is a difference between comma 1 and /1. So it can either accept 0 or 1, but not both. If it is taking 0, 1 is void. If it is taking 1, 0 is void. Okay, so 0, 1, 1, it is fine. So 0, 1, either 1 or 0, it can take. So up to these 3 strings, yeah.
Sir, so that means in NFA, like there might be infinite number of models, right?
Infinite
like
number of models as well as the construction is very, very easy.
Okay.
Sir, in this DFA, from Q2 we can take another state, no sir? Giving input 1 from
But
Q2.
as far as the 3 strings are concerned, we don't require another state.
But can we take, sir?
Final states don't go to any other states. It can only redirect to itself on an input. You can have a state from Q1 to other state like this, Q3. Or from Q0, you can take like Q4. This is the concept I'm about to explain it now, okay?
Q2 to Q0 we can give, no sir?
Yeah, Q2 to Q0 also we can give.
And then it's possible, no sir? 0, 1 and 1.
0, 1 and
0, 1,
1.
1.
You mean 1 on Q2 to Q0?
Yes, sir.
Then it has reached the initial state one. What about the final state?
Okay.
If it want to accept 0, 1, 1, after the third one, it should reach, it should be at the final state.
Final state, okay.
So 0, 1, 1, again your initial, the string is not accepting. But whereas this is possible, 0, 1, you can take 1 and be in the same final state. Okay. So see this now, the basic difference, any problem, we can able to construct an NFA very easily because of the flexibility we had. From one state, we can go to the multiple states on single input or single state on multiple inputs. We have the leverage in NFA, but whereas it is very, very difficult to construct DFA. Okay, we can write this point. For every given machine, for every given finite machine, we can construct NFA very easily, but DFA, it would take a lot of time. Okay. Still, if the string want to accept some more thing, we need to alter the machine. Not that we can have any flexible input in the case of NFA. Okay. So one more thing is concept of dead states. So all of you know the basic dead state. It is a state in which we cannot come back. Okay. So Q0 on 1, it is Q1. Let's say Q0 on 2, it is Q2. So it is 0, Q3 final state. Okay. So see, in this example, Q2 is called as a dead state. Only we can reach the state, but we cannot come out of the state. Say there is no path from Q2 to any other state in the DFA. So such a state is called as a dead state. So now the question is why we are studying this dead state? Because DFA, because of its complex functionality, it can have dead states. But whereas the NFA cannot have dead states, because we cannot get dead states because the functionality is so easy and simple for us to construct any machine such that the machine will never enter a dead state, NFA. But whereas the DFA, as we have this constraint from one state, only one input, we have this constraint. So because of this, for some of the problems, not all the cases, for some of the problems, the DFA may enter dead state, or it need to enter the dead state to accept some strings. To accept some of the strings. Guys, followed? Class, are you following?
Yes, sir.
Yes, sir. Yes, sir.
Okay, అర్థమైంది కదమ్మా ఇది? So an NFA is a very easy machine to construct because of its functionality. Okay, for any given problem, you could able to construct NFA very easily, no doubt about that. But the issue comes with DFA. So let me clear the screen. You need not worry, like if a complex problem is given, how to construct DFA. So don't worry. Most of the cases for DFA, the questions will be deterministic, the same as the machine. Okay. The questions will be very, very deterministic. Accept a string ABA or accept a string 011. It will be very deterministic in nature. Okay. For all the non-deterministic strings, like starting with 01 over the alphabet 0, 1. It can be an any combination, right? So 010, 011, 0101, any combination, it is valid. So for such iterative strings, always the question is asked in NFA. So you need not worry. Okay. Most of the cases for DFA, only the deterministic strings are asked. For example, to accept 0, 1. So simply you can take 0, you can take 1, final state. That's it. DFA done. Whereas in NFA, starting with 0, 1, any iteration. So we have seen just now Q0, 0, that is Q1, 1, Q2. From Q2, we can have 0, 1, any iteration. Okay. So need not worry. Most of the cases, DFA, only specific cases are asked. You can able to compute DFA, but please be very, very clear with the concept. In DFA, from one state to another state, you could reach via only one input. Whereas in NFA, from one state to another state, you could reach via multiple inputs. Okay, this is one-to-one mapping. This is many-to-one mapping or one-to-many mapping also. From the same input, you can reach to different states also. The same 0 you can have here. So Q0 on 0 is Q1, Q0 on 0 is Q0, Q0 on 0 is Q2 also. Okay. So mostly NFA will be asked, DFA won't be asked in most of the cases. Okay. So even the computation of machining also becomes very, very easy for you. Okay.
Sir, so why does DFA exist?
Why does DFA exist? Because it has first came into existence, the basic entity, then the modifications has been done on the DFA that gives rise to NFA.
Okay, sir.
Even the research progresses in such a manner, not only for CSC, for everything also. First, even for a new concept, a novice concept, one researcher begins and research and he proposes something, because at that time, with all available knowledge, that is the best he can produce. After 3 or 4 years, some of his student or his colleague or some other person may challenge his work. That's how all this advancement has come in the technology. Okay. Why DFA exists? That's not the question. DFA was first built by the scientists because of the basic nature. That at that time they don't even thought of having multiple states or multiple inputs. They simply designed the machine like this. So based on the complexity, they have seen, okay, DFA is becoming a tad too difficult to construct and all. So based on this, they have went for the NFA. So why not tweak the machine a little? Why not make it accept multiple inputs? Okay, so that's how the things proceeded. Just because it is somewhat typical, we cannot ignore it, right? It is the first machine. After DFA, NFA had come.
So now it is not, DFA is not used?
No, not that it's not used. It will be used for some of the cases. Everything has its own application.
Okay.
Now, see. Construct an NFA over the 5 tuples. You will be given 5 tuples. So Q0, Q1, Q2. Sigma is 0, 1. Q0 is Q0. F is Q2. So this type of questions can also be asked. You will given the 5 tuples and you are asked to draw the transition diagram. So the transition function is as follows. Delta 0, 1. All of you construct the TD for this NFA. construct the TD, transition diagram. How many states?
3, sir.
So from the given data, we can infer that having 3 states. So Q0, Q1, and Q2. What is the initial state?
Q0, sir.
So in the question, it is given as Q0. So Q0 is initial. Q2 is final, right?
Yes.
So F is given as Q2. So make it final state. Now come to the mapping. Q0 on 0. What is it saying?
Goes to Q0 and Q1.
Yeah. So Q0 on 0, it goes to itself as well as 1. Clear all of you?
Yes.
Q0 on 1, Q1. So Q0 on 1. So already given, right? Sorry, this is 0. Now it's 1. Clear?
Yes, sir.
Sir, Q0 on 1 is, have you written Q1 or Q2?
Q0 on 0, both Q0 and Q1. So Q0 on 0, both Q0 as well as Q1.
Yes, sir. Yes, sir. But in
Q0 on 1, Q1.
So it is Q1. Okay. I thought it's Q2, sir.
No, this is Q1.
Okay.
Next, come to the case of Q1. Q1 on 0, Q2. So Q1 on 0, it is Q2. Q1 on 1, Q0, Q2. So Q1 on 1, it's going back to Q0. And the same Q1 on 1, it's going to Q2 also. So again, it is also 0, 1. Now Q2. Q2 on 0 is Q2. Q2 on 0 is Q2. Q2 on 1 is also Q2. Okay. So this is the transition diagram for the given NFA. Now what's your second hour? CNS, right?
Yes.
Lakshmishwari ma'am.
Yes, sir.
Sir.
I think we have 20 minutes more to go. I try to cover the next concept in this hour. If not, we will take some amount of time for the next hour. I have already informed ma'am also, so you need not worry. Okay. So now the next concept is NFA to DFA conversion. In the Moodle, I have uploaded 7 questions for your practice, my NFA and DFA. I think some of you in your section had already started practicing and asked me via WhatsApp also regarding the doubts and all. Okay, I request all of you to kindly do practice the questions. I will upload more questions by this week. Okay, actually, I'm caught up with some other academic activities like framing the timetable and all these things. As you know, there are many issues coming with the electives. Many students want to change their electives in the midway, so that's why we're facing a lot of heat. Okay, also there is an issue with the LMS Moodle mapping also. So once this week is cleared off, I will be somewhat free, so I will be uploading more and more problems, for you. Okay. And also I'm working on the classroom links as well, the recordings. Okay, there is some issue with my Moodle account. I'm not getting the Zoom session recording links. So I need to access each link from my Zoom page. Okay. So mostly by this end, all the issues will be sorted out. Okay, so need not worry. So the next concept is NFA to DFA conversion. Okay. So just now, as you have seen, DFA to NFA, we cannot convert because both are entirely different. But for NFA to DFA, it is possible. We can make an NFA a DFA, but the reverse is not possible. Okay, so this is also a model of question, very, very important in the examination. You are given an NFA and you are asked to construct a subsequent DFA for it. Okay, so it's very interesting concept. Watch this. So let me take an NFA, a basic NFA. This Q0, A comma B, A Q1, AB is Q2, which is final state. Okay. So this is a basic NFA. Okay. Now I want to construct DFA for this. Okay. So in this problem, the step one is make a table. Given a transition diagram, make a table for your better understanding. Okay. Q0 on A, Q0 right. Q0 on a Q1 also. You have to write like this, set kind of notion. One second, let me make it clear. Q0 comma Q1. Okay. Q0 on B, Q0. So, next Q1. Q1 on A. It is going to Q2. Q1 on B is also going to Q2. What about Q2 more, which is the final state? Nothing, right? From Q2, no paths exist. So write it as phi, phi, not null, not epsilon. It is phi. Okay. So for the given NFA, this is the transition table. The same I have represented in table for better understanding. Okay. Now, watch this very carefully. While going for the next step, the step 2 is, so in the table, take the first row. I'm changing the ink for your reference. See, take the first row. So what are the states in the first row? Just see them. So you see B, it is Q0. Q0 I have already kept in the table, right? So Q0 is already traversed. So Q0 on A, I'm having Q0 comma Q1, right? Q0 comma Q1. So in this conversion, what you will do is merge the two states into hybrid state, or merge the two states into one hybrid state. Now Q0 comma Q1, it will become one state, Q0 Q1. Okay, just merge it now. Then the new merged state, you traverse over the input. Okay, after merging, the new state, which is Q0 Q1, traverse over the input. So what is the input we are having? A comma B. So what's this one? So Q0 Q1, I'm traversing it over A comma B. So Q0 Q1, actually there is no state Q0 Q1. There is a state Q0 separately, there is Q1 separately. But if I have merged these two, how you should look at is, it is Q0 on A union Q1 on A. So for B, it will be Q0 on B union Q1 of B. Okay. So what is Q0 on A? Q0 on A is Q0 Q1. What is Q1 on A? Q1 on A is Q2. The same, Q0 on B. Q0 on B is Q0. So this is Q0 on B. Union Q1 on B. Q1 on B is Q2. All of you clear with step 2?
So one second.
Sir, once more, sir.
Okay. So for NFA and DFA conversion, you will be given an NFA. So for the given transition diagram, make the table, the transition table. So this is step 1. So in step 2, take the first row of the table. So this is the first row of the table, these two fields, right? So in these two fields, observe, is there any new state that is not touched in the table? See, this is Q0. Q0 is already there, right? So you need not worry about this Q0 now. But there is a new kind of occurrence here, Q0 comma Q1. So basically in LFA, we will be having 2 to 3 states, right? Because of the property. So in order to make it DFA, you need to merge the state. So Q0 comma Q1, make it as a new hybrid state, Q0 Q1. This is not comma. This is one hybrid state. Okay. Just like this is A and this is B. If I merge both, it will become AB, a single state. So in the same way, Q0 and Q1, just for time being, assume that it is merged into one hybrid state. Okay. So after in one row, after a new state is merged, this is my new state. So till now there is no Q0, Q1 in my figure. So this is the new state. So the new state traverses over the input. You need to know where the state is going, right? Here, the DFA or NFA is all about states and inputs now, going by the definition. So if a state is there, you should know what is the actions of that state. So Q0 and Q1, we have only two characters of input, A and B in our DFA. So just see what is the actions of the state over the input A, B. So Q0, Q1 on A. See, there is no Q0, Q1. This is a new state. So in order to know the actions of a new state, split the state. Q0, Q1 on A means Q0 on A, union Q1 on A. This is a basic set theory basic. Okay. I think it is distributive property or something. So Q0, Q1 on A, you can view it as Q0 on A and Q1 on A. So what is Q0 on A? See the table. Q0 on A is Q0 comma Q1. So this is Q0 on A part. Q1 on A. Q1 on A is Q2. So this is Q0 part. This is Q1 part. The 3 has come up. Just like Q0 on A is Q0 Q1. Q0 Q1 on A is Q0 Q1 Q2. Clear up to this point?
Yes, sir.
Next, the same over B. Q0 Q1 on B. So Q0 on B union Q1 on B. So Q0 on B is Q0, the same. Q1 on B is Q2. So this is Q0 on B, this is Q1 on B. So this has come. Okay. Now what you should do is, actually this one step I have kept it side for your better understanding. Actually the table will continue as follows. So Q0, Q0 comma Q1, the same I'm writing here now, and Q0. So in the first row I have merged these two as one hybrid state, right? So write it here, Q0, Q1 on A. Q0, Q1, Q2, and Q0, Q2. Okay. Now repeat the same one. So first row we have done, right? So Q0, we have seen Q0 already. Q0, Q1, I have made it as a new state. Now come to the second row. See from the second row, what are the two new states? Is there any state that need to be touched at least once? Okay. See Q0, Q1, Q2. This I can merge, right? Just as in the same previous fashion. Just like I have merged Q0, Q1, I can merge Q0, Q1, Q2. And the same I can go for Q0, Q2 also. One second. See. Now I'm merging these three states. Q0, Q1, Q2. So after a new state is obtained, just traverse it over the same input, AB. So now we have three different states. You should see it as Q0 on A, union Q1 on A, union Q2 on A. Q0 on A. What is Q0 on A? Q0, Q1. What is Q1 on A?
Sir. Can you tell once again how you got Q0, Q1, Q2?
These three I have merged at one.
Okay, so that is now a new hybrid state.
Yeah. All we
okay.
need to do is merge the new states as one hybrid state and check over the input. That's it. It will give me DFA ultimately.
Okay.
Okay. So in the first step, I have merged Q1 and Q0 and Q1 like this. So first row is done. There is no new state. Q0 is already touched. So the same Q0, Q1, if I view it over input A and B, these two has come. So I'm merging this one. Q0, Q1, Q2 had merged at one new state. This is my new state. Again, I'm traversing it over input. So only two steps. Merge the state, traverse over the input. That's it. So Q0, Q1, Q2 on A. So where am I? Q0 on A. Q0 on A is Q0, Q1. For everything, you can view the master table as reference. So Q0, Q1, Q1 on A. Q1 on A is Q2. Q2 on A. What is Q2 on A? Nothing. So you can close the set. No need to write the file. In the same way over B, Q0 on B, Q0, Q1 on B, Q2, Q2 on B, 5, nothing. So close it. Okay, write it here. Every time, I mean, actually you should go in the chronological fashion. No? For your understanding, I'm just writing it side. But you need to continue the table as it is. So what is the new? Is the last time clear?
Yes, sir.
1 second. Better I will write it here. CRs?
Sir?
Just call and inform Lakshmishwari madam that you will be 5 or 10 minutes late to the session.
Okay, sir. Yes.
Just inform her. Actually, I had asked madam for the entire hour permission, but it's not required. I will hardly get the concept done in 5 to 10 minutes. Just inform ma'am that you will be 5 to 10 minutes late for the session.
Okay, sir. Yes.
Thank you. So see here, ma. Now the third step, you should make it here. So Q0, Q1, Q2. This is my new state. And over AB. This is what I have done. Q0, Q1, Q2. And Q0, Q2. Now, see here very carefully, ma. I had merged these three as one state. But previously in the second rows, I'm still in the second row, ma. Don't come to third row still. You are still in the second row. There is a new state, Q0, Q2 to be merged, right? Many of the students commit a mistake here, ma. In one row, they take one state. So they do all the process, they write here and they come to the next row. That's not the process, ma. In every row, you should see all the merged states. Okay, all the new merged states, you need to take it into consideration. Okay, so now see here, Q0, Q1, Q2. I have merged this, but I haven't merged Q0, Q2. Q0, Q1 I have merged, Q0, Q1, Q2 I have merged, but I haven't merged Q0 and Q2. This need to be merged, right? So now merge Q0 and Q2. Same, traverse over the input, A comma B. So Q0 on A. What is Q0 on A? Q0 comma Q1. Q2 on A. Q2 on A is nothing. So close it. Q0 on B. Q0 on B is Q0. Q2 on B. What is Q2 on B? Nothing. So close it. Okay. So now this is the fourth row. You should be adding here. 1 second. Don't get confused. No, the concept is very, very easy than the previous two concepts, NFA, DFA, construction and all. I will reiterate it from the beginning. Don't worry. Just listen it. Very, very easy concept.
Lengthy also, sir.
No. In the future, you can see much more lengthy topics than this. At that time, you will appreciate this thing. Yeah. See, ma, I'm writing the same table here in the reading for your convenience. See this. So I had started with Q0. So Q0 on A is Q0, Q1. I think everyone is clear with this. Q0 on B is Q0. Okay. So in the first step, what you need to do is see the new, two multiple states and merge as one state. I think all of you clear with this.
Yes, sir. Yes, sir.
So see, this is here I had come. So Q0 and Q1 I have merged. This is merged state. So Q0, Q1. So after a state is merged, all you need to do is check over the input. That's it. So Q0 on Q0, Q1 on AB. So Q0 on A, Q1 on A. So Q0 on A, Q1 on A. So this has come. So if I merged Q0, Q1, so Q0, Q1, if I merge, this has come Q0, Q1, Q2. The same Q0, Q1 on B, this has come Q0, comma, Q2. Okay. Now in the second row, okay, now take the second row. See, 3 states, 2 states. These 3 need to be merged. These 2 need to be merged. Okay. So now I'm merging Q0, Q1, Q2 as one. Q0, Q1, Q2 as one state. So now see here, I'm here. Q0, Q1, Q2, I have merged. Traverse over the input A comma B. Same, Q0 on A, Q1 on A, Q2 on A. If there are 5 different states, you need to take all the 5 into consideration. Okay, so Q0, Q1, Q2 on A has given me again Q0, Q1, Q2. Q0, Q1, Q2 on B has given me Q0, comma Q2. Okay, now this one I had merged now. I mean, if you ask me, sir, how to make the, how to merge the states or for what states to traverse, the concept is in the main table or in the first step onwards, see for every row. I mean, check Q0. Q0 is already traversed like this fashion. So that's why I haven't taken Q0. I don't want redundant states. Okay. This should be your process. For a state, if it is not traversed at least once, make that state. If the state has traversed at least once, do not take it. So I'm ignoring Q0 in the first row because Q0 is there itself traversed. So that's why I haven't taken Q0 again. So see this. Q0, Q1 I had taken as a new state. I have obtained Q0, Q1, Q2, Q0, Q2. So now in the second row, first I have merged this one, Q0, Q1, Q2. That has given me 2 new values. Still in the second row, these need to be merged, right? I haven't merged Q0 and Q2. So many of the students, they ignore this state and come to the next one in a bit of hurry, everything will be gone. Okay. So for every row, you should be very careful and see whether all the states have traversed at least once or not. Okay, at least once will be enough. No need of multiple traverse. But check whether each and every state has touched at least once or not. See now, Q0, Q1, Q2 is done now. I need to merge Q0 and Q2, right? So I'm merging Q0 and Q2. So if I merge Q0 and Q2, come here. Q0 and Q2, same on A comma B. So Q0 on A, Q2 on A, Q0 on B, Q2 on B. Say the same table. Q0 on A. What is Q0 on A? Q0, Q1. Q2 on A. Union Q2 on A is 5 marks. So nothing. You can close the set. Q0 on B. Q0 on B is Q0. Q2 on B. Q2 on B, nothing. Close it. So write this. So Q0, Q2 on A is Q0, Q1. The Q0, Q2 on B is Q0. We have merged this state also, right? Come to the next one. Come to third row. Q0, Q1, Q2. Already merged, right? Guys, see here,
Yes,
following
sir.
all of you.
Yes, sir.
So Q0, Q1, Q2, you need not merge because the state is already merged and traversed once. So leave it. Q0, Q2. Q0, Q2 already merged, right?
Yes, sir.
So ignore it. Come to the next row. Q0, Q1 already merged, right?
Yes, sir.
Ignore it. Q0 already traversed at least once, right?
Yes, sir.
Ignore it. That's it, man. Is there any new states to merge?
No, sir.
No, the process is complete. So up to the level at which no new states can be formed, until then you need to continue the process. Clear, all of you?
Yes, sir.
After the session is done in the evening free time, kindly just practice the topic once more. You can get to know how to make the conversion. Also, I will provide you with some examples. Don't worry, okay? Yeah. So this is the process now. 1 second, I have raised the NFA. This is Q1, A comma B, this is Q2. Okay, ma. So first step, make the table. Second step, construct a new table, ma, in which you need to merge the states. NFA, it will be two different set notions, ma, but you make the hybrid states as such. Okay. So once a state is merged, watch it over the input, ma, how it's happening. So you should see in such a way that each state, each of the new merged state is traversed at least once. Okay. Now step 3. This is all step 2, ma. Now step 3. Marking of final states. Marking of final states. Now, this DFA, I mean, this NFA is gone, ma. No longer all the states are there. These are my new states. These are my new states. But now, coming into DFA, we should have final state, right? Now, how to judge upon the final state? That's the question. So, in order to mark the final states in the new states, all you need to do is watch the original NFA. What is the final state in the original NFA?
Q2, sir.
Q2. Okay. So in the new states, what are the states that's having Q2 that will by default become final state? Okay. These two are not having Q2 as a subset of whatever. So only these two are my final states. Clear, all of you?
Yes, sir.
In the original NFA, see the final state. So in the new states, what is the state that having the original NFA's final state? That will be my new final states. So now out of the 4 states, Q0, Q1, Q2 is one final state. Q0, Q2 is also another final state. Now, you need to construct the transition diagram based on this table. Okay. Now tell me, total how many states, ma?
3.
Now watch it very carefully.
4.
4. What is the initial state? U0. What is the another state, ma? U0, Q1. What is one more state? Q0, Q1, Q2, which is the final state, right?
Yes.
So 2 circles. What is the last state?
Q0,
Q0, Q2. It is also final state, right?
Yes, sir.
Now, see the transition function, ma. Q0 on A. What is it showing?
Not Q1.
So Q0 on A. Q0, Q1. Q0 on B.
Q0 only, sir.
Itself, self-flow. So Q0 on B is itself. Come to the new state. Q0, Q1. Q0, Q1 on A.
Q0, Q1,
Q0, Q1, Q2. Q0, Q1 on B.
Not Q2.
Come to the third state. Q0, Q1, Q2. Q0, Q1, Q2 on A.
Same state.
Q0, Q1, Q2 on A. Q0, Q1, Q2 itself. So self-flow. Now Q0, Q1, Q2 on B.
Not Q2.
Q0, Q2.
Q0, Q2. The last state. Q0, Q2 on A.
Q0, Q1.
Q0, Q2 on A.
Q0, Q1, sir.
Q0, Q1. 1 second, guys.
Q0 on B
Ma'am.
is Q0.
లేదు ఒక్క 5 minutes మ్యామ్, ఒక్క 5 minutes. ఓకే, ఆల్రెడీ సిఆర్ ఇన్ఫార్మ్ చేయమని చెప్పాను మ్యామ్ మీకు. ఒక్క 5 minutes మ్యామ్ అయిపోయింది. థ్యాంక్ యూ మ్యామ్. బాబు సిఆర్, అక్షిత్ ఇన్ఫార్మ్ చేయలేదా మ్యామ్కి?
వాట్సాప్ మెసేజ్ పెట్టాను సార్.
బాబు మేడం అంతా వాట్సాప్ లో యాక్టివ్గా ఉంటారు, నువ్వు కాల్ చేయాలి ఇలాంటి విషయాలు ఎవరైనా ఉంటే.
ఓకే సార్.
ఓకే, నో ఇష్యూ. యా, సో Q0 on A is Q0 Q1 మా. Q1 ఏనా? Is it Q1 or Q2, guys? Yeah, Q1. So Q0, Q2 on A is Q0, Q1. Q0, Q2 on B.
Q0.
Now, is this DFA or NFA?
DFA, sir.
DFA, sir.
You can very clearly say that it is a DFA now, because from one state on one input, it's going to altogether a new state. No multiple paths are there. Okay. So this is NFA to DFA conversion. Clear, everyone?
Yes, sir.
Or still some doubts here and there?
No doubt, sir.
So simple math, 3-step approach. Step 1, make a table. Step 2, make a modified DFA kind of table, wherein you merge the states as one state and traverse over the input. Okay. Step 3, mark the final states. So whatever the original final state is there in NFA, mark it as a new final state. Step 4, make it a TD. So this NFA is now converted into DFA like this. Now you can see the complexity. For the same machine, see the NFA and see the DFA. Okay, that's why NFAs are very easy to construct. DFAs are very complex to construct. Okay, you see only one final state here, two final states here. Simple paths here, complex paths here. Okay. So this is about NFA, DFA, and NFA to DFA conversion. The first 3 topics are successfully completed. Okay.
Yes, sir.
Guys, are you satisfied with my explanation?
Yes, sir.
Yes, sir.
No
Yes,
issues,
sir.
right?
No issues, sir.
No issues.
I'm not sure whether I'm bringing the justice to this subject or not you for this section. Okay, that's neat. That's what I need to be very, very clear, because as I told you, I should let go of one section.
Sir, nice only.
Okay. You are satisfied, right? No issue, right?
Yes, sir. No
Yes,
issues.
Yes, sir.
Okay,
No issues.
then it's fine. So actually, I have told you that I was in a bit of all other stuff and all. That's why I couldn't that much be crisp on this concept. Once the first mid is over, the things will be very, very clear and crisp for you. Okay, I will make the things much more easier for you. Okay.
Okay.
Yeah. Thank you all. Thank you for your time. That's it for today, ma.